The lack of curiosity in new generations about Neptune is quite concerning. Despite what we've been told, Neptune is not what it seems. This distant, icy giant at the edge of our solar system has been a mystery for decades. Neptune's strange atmospheric phenomena and unexplained anomalies in its magnetic field show that there is much more to this planet than we understand. With winds reaching 1,500 miles per hour, the fastest in the solar system, there is still so much to discover about Neptune, and it could change everything. The mysterious icy giant. Neptune, the 8th planet from the Sun, is the most distant ice giant in our solar system. It's known for its deep blue color and intriguing features, making it a favorite among astronomers. Neptune is huge, with a diameter of about 49,528 kilometers, making it the 3rd largest planet by size and the 4th largest by mass. Its composition includes hydrogen, helium, and ices, like water, ammonia, and methane. These ices are responsible for its unique blue color. Neptune's atmosphere is extremely dynamic and complex. It's made mostly of hydrogen and helium, with some methane, which plays a big role in its blue appearance. Methane in the atmosphere absorbs red light and reflects blue light, giving Neptune its striking color. The atmosphere also has clouds of methane ice and other materials. Neptune is known for having the fastest winds in the solar system, with speeds reaching up to 2,100 kilometers per hour. These strong winds help create dark storm systems and large, rotating storms, similar to Jupiter's Great Red Spot. Neptune has a strong magnetic field, which is tilted compared to its rotational axis. This magnetic field is generated by the movement of electrically conductive fluids within the planet, similar to how other gas giants create their magnetic fields. Neptune's magnetic field extends far into space and interacts with the solar wind, forming a magnetosphere. Inside Neptune, there is a rocky core surrounded by a layer of water, ammonia, and methane ice, all covered by a thick outer layer of hydrogen and helium. The planet's magnetic field and internal heat contribute to its stormy weather and atmospheric activity. Neptune also has a ring system, though it's not as prominent as Saturn's. The rings are made up of small particles and dust, with some faint dark rings and a few narrow bright ones. These rings are named after astronomers and mythological figures, such as the Adams, Leverrier, and Gall rings. It's believed that the rings may have formed due to the interactions between Neptune's moons and the ring material. Speaking of moons, Neptune has 14 known moons, with Triton being the largest and most interesting. Triton is unique because it orbits Neptune in the opposite direction of the planet's rotation, suggesting that it was likely captured by Neptune's gravity rather than forming alongside it. Triton is also known for its geysers that shoot out nitrogen gas, hinting at an active subsurface ocean or cryovolcanism. Other moons include Proteus, Nereid, and Despina, each with their own distinct features. Exploration of Neptune started with telescopes on Earth and space missions. The Voyager 2 spacecraft, which flew by Neptune in 1989, gave us the first close-up images and detailed data about the planet. This mission revealed Neptune's active atmosphere, its ring system, and large storms like the Great Dark Spot. Voyager 2 also provided important information about Neptune's moons, especially Triton and its geysers, greatly improving our understanding of the planet's atmosphere, weather, and moons. A storm larger than Earth. Since Voyager 2 passed by Neptune in 1989, scientists have been puzzled by the large dark spots that appear in the planet's atmosphere. These mysterious patches have intrigued astronomers for decades. For the first time, scientists have observed one of these spots using instruments on Earth with incredibly high detail, helping to explain why these spots look so dark and why they are different from spots on other planets. Astronomer Patrick Irwin from the University of Oxford in the UK has always been curious about these dark spots. Ever since the first dark spot was discovered, "I've wondered what these short-lived and hard-to-find dark features are," Irwin said. "I'm really excited to have not only detected a dark spot from the ground for the first time, but also recorded a reflection spectrum of one of these spots." Neptune's dark spots are actually storms, similar to the Great Red Spot on Jupiter, but they have some key differences that make them unique. These storms do not last as long as those on other planets. They appear and disappear every few years. The centers of these storms seem to have fewer clouds compared to storms on Saturn and Jupiter. The clouds that are visible are white and fluffy, usually forming around the edges of the storm. Scientists think these clouds form when gases freeze into methane ice crystals as they rise from lower parts of Neptune's atmosphere. However, learning more about these storms has been difficult because Neptune is so far away, and the storms do not last very long. Since 1994, the Hubble Space Telescope has been the only tool capable of observing and tracking these storms on Neptune, but it can only see the planet in a limited range of wavelengths. When a large storm appeared in 2018, Irwin and his team decided to use a different tool, the Very Large Telescope's Multi-Unit Spectroscopic Explorer, MUSE. MUSE could detect sunlight reflecting off Neptune and split it into different wavelengths to create a 3D spectrum of the planet. This allowed the researchers to determine the altitude of the dark spot, leading to a surprising discovery. The dark spot was not a hole in Neptune's atmosphere, as some had thought. Instead, the dark color seemed to come from particles in a layer of hydrogen sulfide below Neptune's atmospheric haze. The researchers think that the dark color might be caused by local heating in the deep part of the storm, which turns the hydrogen sulfide ice into vapor, revealing a darker core of the storm. Their observations also suggested that the particles in the layer above became smaller, making the atmosphere less cloudy. The researchers found another surprise, a bright cloud near the dark spot. This cloud was not like the usual methane clouds that often appear with Neptune's storms. Instead, it was a type of cloud that had never been seen before and seemed to be at the same altitude as the dark spot. Scientists still need to investigate further to understand what this bright cloud is and if the team's ideas about Neptune's dark spots are correct. However, with the ability to observe Neptune from Earth now possible, we are closer to finding answers. "This is a big step forward in our ability to observe space," said astronomer Michael Wong from the University of California, Berkeley. "At first, we could only see these spots by sending a spacecraft like Voyager. Then we could spot them remotely with Hubble. Now, thanks to advanced technology, we can observe them from the ground." Observation of Neptune. Neptune is the only giant planet that cannot be seen without a telescope. Its brightness is measured as an apparent magnitude of 7.8, making it about 1/5 as bright as the faintest stars visible to the naked eye. This means that no one could have observed Neptune before telescopes were invented. Galileo was the first person to look at the stars through a telescope in 1609. He made sketches a few years later, with one sketch made on December 28, 1612, suggesting he might have seen Neptune when it passed near Jupiter. However, he did not recognize it as a planet. Before Uranus was discovered by William Herschel, an English astronomer, in 1781, scientists believed there were only 6 planets in the solar system. These included Earth and the 5 planets known since ancient times. When Herschel discovered Uranus, it sparked curiosity about the possibility of more planets. One idea that excited scientists was Bode's Law, developed by Johann Daniel Titius in 1766. He noticed a pattern in the distances of the known planets from the Sun. For example, Mercury is about 0.4 astronomical units, AU, from the Sun. The distances of Venus, Earth, Mars, Jupiter, and Saturn followed a specific formula. Bode published this idea in 1772, suggesting that there might be another planet between Mars and Jupiter. At first, people were not very interested in Bode's Law. However, When Uranus was found, its distance of 19.2 AU was close to what Bode's law predicted. The discovery of Ceres, the first asteroid in 1801, which was located between Mars and Jupiter, supported the idea of more planets existing. Some astronomers were so impressed by Bode's law that they suggested naming a hypothetical planet beyond Uranus Ophion. They thought this planet would be about 38.8 AU from the Sun. However, Uranus was not following the path predicted by Newton's laws of motion, leading scientists to think another planet's gravity might be affecting its orbit. In 1843, British mathematician John Couch Adams began searching for the location of this new planet. He shared his findings with George B. Airy at Greenwich Observatory, but they were not detailed enough to start a search. In 1845, French astronomer Urbain Jean-Joseph Leverrier began his own calculations without knowing about Adams's work. By mid-1846, John Herschel, the son of William Herschel, believed that mathematical studies could lead to finding a new planet. Airy proposed searching based on Adams's calculations. James Challis at Cambridge Observatory began examining the area Adams suggested, facing challenges due to a lack of maps. Leverrier had difficulties convincing astronomers in France to look for the new planet. On September 23, 1846, he communicated his findings to Johann Gottfried Galle in Germany. Galle and his assistant, Heinrich Louis d'Arrest, used detailed star maps to identify Neptune as a new star that night. While Galle and d'Arrest were the first to see Neptune, Leverrier's calculations were essential in locating it. There were discussions about naming the planet after Leverrier, but this idea did not gain much support. Eventually, both Adams and Leverrier received credit for discovering Neptune, with names from ancient mythology being used for planets. Neptune's discovery ended Bode's law. Instead of being near 38.8 AU, Neptune is actually 30.1 AU from the Sun. This difference and the lack of a scientific explanation for Bode's law discredited it. The discovery of Pluto in 1930 at 39.5 AU further contradicted Bode's predictions. Observing Neptune from Earth was challenging due to its great distance. Sunlight reaching Neptune is only about 0.1% as bright as on Earth. Early telescopes could not capture fine details of Neptune. However, in the early 21st century, new techniques improved observations. The Hubble Space Telescope and Spitzer Space Telescope captured clearer images. Adaptive optics technology also helped reduce distortions in images from Earth. These advancements allowed astronomers to study Neptune closely, revealing fascinating information about this distant planet. Neptune's atmospheric secrets. Neptune is the 8th planet from the Sun. Scientists are very interested in Neptune because it has strange weather, even though it is very cold, with temperatures around -200 degrees Celsius. Despite the cold, Neptune has powerful storms that can last a long time, making its atmosphere a mystery that scientists want to understand. Researchers Karen Aplin from the University of Oxford and Giles Harrison from the University of Reading studied Neptune's weather in a paper published in Nature Communications. They looked at two main things that might cause Neptune's unusual weather: sunlight and cosmic rays. Scientists used to think these two worked separately, but this study suggests they work together to affect the planet's atmosphere. The research started in 1972, when scientists measured how bright Neptune was and studied how sunlight and cosmic rays influence the planet. Cosmic rays are high-energy particles that come from space and can take away electrons from molecules in Neptune's atmosphere. Changes in sunlight help form clouds, and together, these forces create the wild weather seen on Neptune, including swirling storms that can last for years. Neptune's atmosphere is mainly made up of hydrogen, helium, and methane. Methane is important because it absorbs red light. This absorption makes Neptune look blue when viewed from Earth. The planet has very strong winds, reaching speeds of up to 2,100 kilometers per hour, which are some of the fastest in our solar system. These winds create big storms, like the Great Dark Spot, which lasted about 5 years. Neptune's atmosphere has different layers. The lowest layer is called the troposphere, where weather happens and temperatures get colder as you go up. Above this is the stratosphere, where temperatures get warmer. The line between these two layers is called the tropopause. Higher up is the thermosphere, where temperatures are surprisingly high, around 750 Kelvin, about 477 degrees Celsius. Scientists don't know why the thermosphere is so hot. One idea is that the heat comes from interactions between the atmosphere and Neptune's magnetic field. Another possibility is that gravity waves from inside Neptune create this heat. The upper atmosphere of Neptune has different kinds of clouds. For example, methane clouds are found at lower pressures, while clouds of ammonia and hydrogen sulfide may form at higher pressures. The deepest clouds, found at pressures around 50 bars, could be made of water ice. High clouds on Neptune have been seen casting shadows on clouds below, which shows they are part of the troposphere where the weather occurs. Sometimes, these clouds disappear, like in August 2023, when high-altitude clouds vanished. Scientists linked this to solar cycles, not Neptune's seasons. Neptune's atmosphere also has small amounts of other gases, like carbon monoxide and hydrogen cyanide, found in the stratosphere. These hydrocarbons make Neptune's stratosphere warmer than Uranus. Even though Neptune is far from the Sun, its atmosphere is still active and changing. NASA's Voyager 2 spacecraft helped gather important information about Neptune, allowing scientists to learn more about its atmosphere. Studying Neptune is important because it helps us understand the complexities of other planets and their atmospheres. What's really happening on Neptune? Neptune has its own magnetic field, which was discovered by the Voyager 2 spacecraft in 1989. Neptune's magnetic field is like a bar magnet, just like Earth's, but there are some differences. While Earth's magnetic field points north, Neptune's magnetic field points south. This means that if you used a compass on Neptune, it would point to the south instead of the north. Earth's magnetic field comes from electric currents flowing in its liquid iron core. Other giant planets, like Jupiter and Saturn, have magnetic fields created by electric currents in their outer layers, which are made of liquid metallic hydrogen. For Earth, Jupiter, and Saturn, their magnetic fields are centered inside the planets and point in the same direction as the planets spin. But Neptune's magnetic field is tilted about 47 degrees from its rotation axis, and Uranus's magnetic field is tilted even more, nearly 59 degrees. Another interesting thing about Neptune's magnetic field is that it is not centered in the planet. It is shifted 55% away from the center, meaning it is closer to the clouds than to the planet's center. Scientists think that Neptune and Uranus make their magnetic fields from processes happening in the upper layers inside them. Neptune's magnetic field looks like an apple, with the top and bottom pointing toward the magnetic poles. The solar wind, which is a stream of charged particles from the sun, pushes against this shape. This makes the magnetic field compressed on the side facing the sun and stretched into a long tail on the side facing away from it. The area affected by Neptune's magnetic field is called its magnetosphere. In Neptune's magnetosphere, there are fewer charged particles compared to the magnetospheres of other giant planets. Some trapped particles can escape and hit Neptune's atmosphere, creating bright lights called auroras. However, these auroras are not as strong as those on Earth. Neptune is the densest of the giant planets, even though its average density is slightly less than 30% of Earth's. This means a larger part of Neptune's interior is made of melted ice and rocky materials compared to other giant planets. Scientists do not fully understand how these heavy materials are arranged inside Neptune. Data from Voyager 2 shows that Neptune probably does not have a clear inner core of molten rock, which was once believed. Neptune takes about 16 hours to complete one rotation, which is longer than expected for a planet with a layered interior. Scientists think the heavy materials might be evenly spread throughout Neptune, making it more like Uranus than the bigger gas giants, Jupiter and Saturn. Lastly, the heat inside Neptune may not mean it is hotter at its center than Uranus. Neptune's multiple layers could trap heat better than Uranus does. Observations show that the activity in the atmospheres of both Uranus and Neptune is more affected by sunlight than the heat escaping from their insides. Neptune's influence on the Kuiper Belt. Neptune is a fascinating planet located far from the Sun in our solar system. It spins around its axis 89,630 times every year, which equals about 165 Earth days. This means that each season on Neptune lasts around 41 Earth days. The blue color of Neptune comes from its atmosphere, which is mainly made up of hydrogen, helium, and methane gas. This gas reflects sunlight, giving Neptune its beautiful blue hue. Neptune also has a significant effect on the Kuiper Belt. The Kuiper Belt is a vast region beyond Neptune filled with icy minor planets and other celestial objects. It is similar to the asteroid belt between Mars and Jupiter, but is much larger. The Kuiper Belt starts at about 30 astronomical units from the Sun and stretches out to 55 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun, which is about 93 million miles. Because Neptune is so close to the Kuiper Belt, its strong gravitational pull influences many objects in this area. Throughout the history of the solar system, Neptune's gravity has changed the Kuiper Belt, creating gaps in its structure. These changes happen because of something called secular resonance. This concept means that the orbits of certain objects in the Kuiper Belt are affected by the movement of Neptune. When an object's orbit around the Sun matches Neptune's orbit, they help stabilize each other's paths. For instance, if an object takes twice as long as Neptune to orbit the Sun, it will travel half the distance while Neptune completes its full orbit. One of the busiest regions in the Kuiper Belt has more than 200 known objects that are in a special relationship with Neptune, called a 2-to-3 resonance. In this relationship, these objects complete one full orbit around the Sun for every 1.5 orbit that Neptune makes. These objects are known as Plutinos, a name inspired by Pluto, which is one of the largest objects in the Kuiper Belt. Even though Neptune and Pluto have orbits that are very close to each other, the 2-to-3 resonance keeps them from colliding. Additionally, Neptune has many Trojan asteroids that follow it in its orbit, almost like little companions. These Trojans are also in a 1-to-1 resonance with Neptune, meaning their orbits are stable and closely connected to Neptune's path around the Sun. Future missions to Neptune and Triton. Since 2018, the China National Space Administration has been working on a project for 2 space probes called Shenzhou, which are similar to the Voyager probes. These probes are set to launch in the 2020s. They will travel different paths to explore the heliosphere, the area of space influenced by our Sun. The second probe, named IHP-2, is scheduled to fly by Neptune in January 2038. It will come very close to Neptune, just 1,000 kilometers above its clouds. There is also a plan for this probe to release a small device into Neptune's atmosphere as it approaches. After IHP-2 and Voyager 2 visits Neptune, scientists think the next big step for exploring Neptune's system will be sending an orbiter, which is a spacecraft that goes into orbit around a planet. Most ideas for this kind of mission have come from NASA. They hope to send a big orbiter to Neptune in the late 2020s or early 2030s. However, there have been talks about launching missions to Neptune even sooner. In 2003, NASA suggested a mission called the Neptune Orbiter with Probes. This mission would collect a lot of important scientific data, similar to what the Cassini spacecraft did when it studied Saturn. Another idea was for a spacecraft called Argo, which was supposed to launch in 2019. This spacecraft would visit Jupiter, Saturn, Neptune, and an object in the Kuiper Belt, focusing mainly on Neptune and its largest moon, Triton, around 2029. There was also a mission called New Horizons 2, which would have made a close flyby of Neptune, but it was cancelled. Right now, there is a proposal for a spacecraft named Trident to fly by Neptune and Triton. Unfortunately, this mission was not chosen in the latest selection rounds for the Discovery program. NASA is currently studying a new mission concept called Neptune Odyssey. This mission would send an orbiter and an atmospheric probe to Neptune, with plans to launch between 2031 and 2033 and arrive at Neptune by 2049. Two interesting proposals focus on Triton, Neptune's moon. These missions, called Triton Ocean World Surveyor and Nautilus, would have timelines that fall between the Trident and Odyssey missions. Triton Ocean World Surveyor would take place from 2031 to 2047, while Nautilus would happen between 2041 and 2056. Lastly, there is potential for China's Tianwen-5 mission to target Neptune, with an arrival expected in 2058. We hope you enjoyed this video. Stay tuned for more.